Yes, sir.
Start with sir. We can start. Energetics. Energetics chapter in O level. Most of the time, questions are coming in your final exam. So you have to give importance. Energetics. Mainly here we'll discuss regarding how to calculate enthalpy change. If you enforce here, it will be easy for you. These are the topic you have to study. After this lesson, after this chapter, you will be able to learn meaning of enthalpy change. Yeah, mainly calculation, but first you have to know the meaning, then
How to calculate it?
bond making, then profile diagram, simple calorimetric experiment. And the last one, you see calculation, I told you. If you know calculation, everything will be easy. And some practical investigation. Practical investigations is related to your laboratory work. So let's discuss deeply. The first one, enthalpy change. Enthalpy change is delta H. It is expressed by del H. Change of enthalpy, enthalpy change. Enthalpy is heat content. So the enthalpy change, if you define here, uh, amount of energy change per mole. Okay, energy change divided by mole. This is the enthalpy change. The unit is kilojoule per mole. Heat change per mole. Heat change per mole. Heat change per mole, right? Is the enthalpy change. So
Yes.
heat change is kilojoule, mole is the mole. So heat change per mole is the enthalpy change. Q is equal to mc del theta. This is the formula you know. Is equal to mc del theta. M is here amount of solvent or the liquid actually. C is the specific heat capacity, del T temperature change. In physics also you have studied this one. So M is the mass, C is the specific heat capacity, del T is the temperature change in Kelvin actually. So if you know heat change divided by mole, you can calculate enthalpy change. Enthalpy change is delta H. Clear to you, Farhan, regarding the enthalpy change? I try to give you the mathematical explanation. Farhan, clear? Then the next one. Next one, enthalpy change two. Yeah,
Yes.
and
Sir, can you repeat what you said? Everything. Can you
it-
repeat what you said? Nothing clear.
everything repeating will be boring. Later on, you'll see I'll coming again. So enthalpy change is heat change per mole. Just you see the definition. You have to be every moment. You have to be attentive, right? When you are not getting, you have to respond. Otherwise, I can
Yeah.
understand. Enthalpy change two types: endothermic and exothermic. Endothermic means heat
Mm-hmm.
absorbed, positive. And exothermic means energy releases. If you see here, exothermic reaction, delta is negative. Any type of combustion reaction, exothermic reaction, is giving you heat. If you give hot water in a glass, the hot water will release it, right? The system is exothermic. Reaction between acid and alkali, neutralization reaction, exothermic. In our body, the respiration reaction is occurring, right? When we take food, our body is processing to produce energy. This is exothermic actually. Combustion, any type of combustion, exothermic. There are some exceptions actually. Nuclear reactions, if not the chemical reaction, this is exothermic. Endothermic, if you add water to ammonium nitrate, this is endothermic. And water to potassium chloride, this is also endothermic. It will be colder, okay? If you give a few pieces of ice cube in a glass in your dining table, it will take heat right from the surroundings. The system is endothermic actually. Cold water will take heat. Hot water will release heat. So cold water is taking heat from the surroundings. This is endothermic system. Any type of decomposition reaction is endothermic. Decomposition means breaking down to a compound. Say if you heat up calcium carbonate will be broken down to calcium oxide and carbon dioxide. This is endothermic. And you know, in biology you have studied photosynthesis. Photosynthesis is the endothermic system. So now bond breaking and bond making concept. If you say here bond chlorine chlorine single bond covalent bond is broken, you need energy, right? And bond you are making two chlorine atoms from the chlorine molecule. This is bond breaking. Any type of bond breaking is endothermic because you need energy, right? If you want to break a small piece of brick, you have to apply energy, right? You have to force to break it down. So this is endothermic system. You see here. Single bond energies, hydrogen, hydrogen 436. What will be the bond energy of oxygen, oxygen single bond? 146. Chlorine, chlorine 242. Similarly, double bond, triple bond given here. You have to have this data. If you have to have this data, you can calculate. If you look here, um, hydrogen chlorine reaction in making hydrogen chloride. First one reactant is hydrogen and chlorine. First we want to calculate bond breaking energy. Hydrogen, hydrogen, how much bond energy? 436, right? Chlorine, 242. So getting total 678 kilojoule per mole bond breaking energy, positive. And the bond making energy here, hydrogen and chlorine. If you look here, hydrogen and chlorine, we are putting here negative because bond making, right? Bond is making, so we are putting here negative. You look, if I you see here negative, right? That is bond making multiplied by 2 because 2 bonds, so total bond making energy negative 7 sorry 8 is 8 is 872. So which one is bigger, bond making or making? 678 and 872. Here bond making is greater, bond making energy is greater, that is exothermic. You have to remember, when making energy is greater, that is exothermic. So delta is enthalpy change is difference between these two. So positive 678 negative 872, you are getting negative 194. This is the enthalpy change actually. So if you know this, if you understand this calculation, you can understand this concept of this chapter. Another one calculation, you look here, it's broken down to water and oxygen. This is decomposition reaction. We want to calculate. We want to calculate the enthalpy change. First one, bond making energy. It's similar, right? I'm showing you first quickly. This is bond making. Which one is greater, making or breaking? Still here, making is greater. So enthalpy change is negative 206. Have you understood, Farhan? Clear to you? Okay, to response sometimes. This one,
Yes.
another example, C2H5OH.
Yes.
This is ethanol and water. You are getting carbon dioxide and water. So this reaction, you have to do it. Data given. So take the screenshot. This is your homework. You have to complete in your home, and they have to compare with my answer. Can you take the screenshot of this one? Only this page. This will be your homework, or you can take the picture by your phone. Okay, done. Done.
Taken.
Okay, you have taken. Then
No, I took
another one.
yes.
Breaking energy, bond making energy, the similar type, right? Where data is given, you can also do it the same way. If you know this structure formula, it will be better for you, right? The CH, uh, 4 carbon hydrogen bonds, 2 oxygen bonds, and here carbon oxygen bond 2. So it is quite easy, you can do it. Another one, you look here, bond making energy, methane plus oxygen, combustion reactions, carbon dioxide and water. I'm showing you again bond breaking energy, bond making energy. Here bond breaking is greater, so delta H is negative 802. So another problem you have to do in your home, you can take the screenshot of this one as well. So bond breaking and bond making, you have to calculate as well as delta is the same way. When bond making is greater, that will be exothermic. You just have to remember. Another one, I'm showing you the calculation. It is quite easy. C2H6 and water produce the bond breaking energy, bond making energy. Here bond making is greater again, so exothermic. Another home task you have to do in your home. So how many I've given you? 3. You can take this one as well, the screenshot or the picture by you. And so for this one, you have to
Wait,
pick
sir.
the data in the previous. So have you taken the screenshot? But for this one, I have not given you the data, so you have to pick as well. So done maybe. So I'm going another.
I took this one and
Yeah,
I still have
another 2.
the
So total
other
3
one, the one
task
that you showed at the second
I
time.
gave you to calculate to your home. Turn on my sim. Then enthalpy profile diagram. Enthalpy change. Actually, you have the bit idea. We want to discuss about the diagram. If you look here, energy change by enthalpy profile diagram for exothermic reaction. In the x-axis probability of reaction, y-axis energy. If you look here, this is reactant product. Can you understand this one? What will be the product? What will be the reactant? The blinking is the reactant, energy level of the reactant. This amount of energy for the reactant actually, this amount of energy. Okay, for product has lower energy, so this is called activation energy. Activation energy and the enthalpy change, difference between the energy of reactant and the product, this will be the negative, right? So activation energy is the minimum amount of energy needed to start a chemical reaction. This is very, very important for you. That is barrier. Higher the activation energy, that is less reactive, that is unreactive almost. Smaller the activation energy, it is very reactive. So reactive metals have a lower activation energy, but nitrogen gas has higher activation energy. Inert gases has higher and higher activation energy, so they don't take part in chemical reactions. Another one you have to know for endothermic reactions, y-axis energy, x-axis progress of reaction, energy of reactant. You look here, this amount of energy for the reactant, and the product, this amount of energy. Product has higher energy, so here you can predict. Similarly, activation energy and delta H. Delta H is positive here, enthalpy change. Though this is enthalpy profile diagram, so you have to show these 4 points. Understand? Level of reactants, products, activation energy, and enthalpy change.
Yes, sir.
Just enthalpy diagram, you don't have to show the activation energy. Okay. If I ask you, just draw the enthalpy diagram, you don't have to show the activation energy. Another one I want to show here, catalyzed system. If you know here, this is catalyzed because if you use catalyst, activation energy lowered, right? In presence of catalyst, you need less amount of activation.
Yes.
So the broken line, green line, you look here, this is the presence of catalyst, activation energy decreases. Another one, this is for endothermic reaction catalyzed system. It has lower activation energy. Others are okay. Just in presence of catalyst, activation energy is lowered. So now this is the homework you have to do in your home. The first one, hydrogen and oxygen, H2O. This is exothermic reaction. I'm giving you the clue. And the second one is the endothermic reaction. So I think for exo and endo, you can draw the energy profile diagram. You take the screenshot as well. This one, the profile diagram, energy profile diagram, you have to, or enthalpy profile diagram, you have to draw for these two reactions. Have you taken, Farhan? Then for the normal system
Yes.
and the catalyzed system, that is broken, including the broken line, you have to show. Then another example, just I'm giving you, you look here, hydrogen and chlorine, hydrogen chloride here, the enthalpy change is, you look here, negative 184, right? So how much heat energy will be changed? For this, you need the moles first. You have to calculate the moles of hydrogen, 1.25. Moles of chlorine is 2. So moles of hydrogen is smaller. So chlorine is the excess. So the product will be depends on the limiting reactant. So amount of heat per mole 184. So 1.25 moles multiply. So 230 is the answer. Understand? The second question, can you predict what will be the answer? Explain why the
Yes.
reaction is exothermic. In terms of bond breaking and making, answer will be bond making is greater than the bond breaking since it is exothermic reaction. Another
Breaking.
one. Another one I'm giving you regarding the calculations of enthalpy change. You know here delta is enthalpy change 49 kilojoule per mole. Enthalpy change is kilojoule per mole, but you have to calculate how much heat energy is released. So for that you have to find out the moles first. What's the moles of hydrogen gas? Is 500 kilogram. You have to convert it to the gram, and the moles is 250,000, right? Moles. So per mole 49. Sorry, 3 moles hydrogen you are getting 49. For one, how much? And 259. So it is just unitary method. You can do it. Other calculations you can do it. This endothermic system, the simpler. You have to find the moles of hydrogen first. Moles of hydrogen 5000, and then for 3 moles hydrogen you are getting 21 kilojoule, and 5 into 10 to the power 5, how much? It's simple. Similar way you can do it. Another one. This chapter is related to your energy, right, Farhan? So for this one, we are concerned to fuel cell, hydrogen of fuel cell, and oxygen. Hydrogen and oxygen gas are used. This is really good invention, but still it is not commercially uh, viable. So hydrogen gas is a renewable fuel. It is very much effective, not harmful for the environment. But large scale production still it is challenging because of hydrogen gas is highly flammable and you have to store it in high pressure. Here the solvent is need sulfuric acid. Hydrogen gas is coming this side and making electrons. Electron is coming through the wire, and the H plus ion is coming this side. Reacting with oxygen, you're getting energy as well. I've discussed hydrogen fuel. A similar type of another fuel is alcohol. Alcohol also renewable fuel. It is environment friendlier than the traditional fuel. So experiment, I want to discuss one experiment. If you see here, copper sulfate and zinc needs to react and making zinc sulfate plus copper. This is exothermic reaction. Here the amount of copper sulfate 100 cm cube. If you look here, 100 cm cube, amount of zinc 2 gram. So temperature, initial temperature 25, we are considering the final temperature, let's say 35. So temperature change is 10 Kelvin. This is important. So heat change Q is equal to mc del theta. M is here the amount of substance where thermometer is inserted. So 100, 4.2 specific heat capacity. So you are getting 4.2 kilojoule. Then you have to calculate the mass of zinc is given, and the mass of and the MR is 65, so you're getting 0.03. So the mass is 0. Sorry, enthalpy change 4.2 divided by 0.03. Also, it will be negative, right? This is exothermic reaction. So this type of experimental setup is not so important, but if you have the idea and if you do in your lab, your investigative knowledge will increase. Another experiment you have here, you can calculate the enthalpy change. You can investigate the enthalpy change for this system. For this one, the first one you have to find the Q for this one. Temperature change you have to measure. The mass is given, so if it's not given, we can do it. Farhan, are you getting my point? Yeah, first you have to find the heat change, right? Heat change for this water is given 200. Specific heat capacity of water actually 4.2, and the temperature change, how much temperature you have to calculate from here, initial temperature and the final temperature, right? You have to, this will be the joule, you have to convert it to the kilojoule, dividing by 1000, right? You can do it easily. Then you have to find the mass of methanol from here, initial amount of methanol and the final amount, the difference will be burnt, right? So the mass, if you m methanol, mr of methanol, you have to calculate. Formula of methanol is actually, you know, so far CH3 wise. So from here you can find the mole. If you know the mole and if you know the heat change, you can find delta H easily, right? It will be thermic Q by M.
Yes.
This is your expression. After this chapter, I'm again making a summary. I'm going to the first point. In this chapter, energetics, actually enthalpy change calculation. So these are the points you have to know. The first one, enthalpy change. Maybe you have the problem here. Enthalpy change, amount of heat change per mole. This is the main thing. Amount of heat change per mole. This line, Farhan. This line you have to understand. Heat change per mole. For one mole amount of heat change is the enthalpy change. Sometimes it is positive, sometimes it is negative. For positive endothermic, negative exothermic, example of exo and endo. Also bond making and breaking concept. This is very important. I gave you so many home tasks to clear your understanding. And
Hmm.
next one, I have shown you the profile diagram. This is very important. I also gave you the homework to clear your understanding in my class. So another one I have discussed regarding your investigative point in your laboratory so that you can understand enthalpy change clearly. Up to this, your chapter of energetics or the enthalpy change. Mm, Recording of Kuri.